Okay, a very good afternoon to all of you. So we are going to start a brand new chapter, which is chapter 6, group 17. So as usual, we are going to start off with objective questions. So without hesitation, let's begin our lessons. Okay, so we start from objective question number 1. Sounds like this. The reaction scheme below shows us the reaction between aqueous solution of P with several reagents. So you form brown solution. Now this is a very important clue. Brown solution when you react with concentrated sulfuric acid, and then you form silver. When you react with silver nitrate, you form a cream precipitate, and then you react with lead nitrate, it also gives a cream precipitate. So all these are trying to tell you that the ion is what ion? It is a bromide ion. So because it is a bromide ion, so the best P is potassium bromide. Okay, so that is for number 1. Then number 2, which of the following is the uses of halogen and its compound? So halogen is, now soap and detergent are made from sodium carboxylate, RCOONA, and alkyl benzene sulfonate, RCCH5SO3Na. So therefore, it is not a halogen compound. So number 1 is wrong. Okay, so black and white uses AgBr, which is correct. Sterilization of water uses Cl2, which is also correct. And propellant in aerosol uses CFC, which is a chlorofluorocarbon. So also correct. So the best answer in here is 2, 3, and 4. Therefore, the answer is D. Immediately we move to question number 3. Which of the following is one of the product between bromine and potassium hydroxide under room temperature pressure? So in here you have to know what are the reactions outcome in here. So in bromine and iodine react with potassium hydroxide to straight away give potassium bromide and potassium bromate 5. Okay, so you produce KBr, KBrO3, and H2O. So the answer is 2, 3, and 4. Okay, so the answer is also D. Number 4, an aqueous solution of Q has the following properties. It reacts with aqueous silver nitrate to form a precipitate which dissolves in excess ammonia. And then it reacts with aqueous sodium hydroxide to form salt and water. And then decompose on the presence of sunlight to evolve gas. So these are trying, all these 3 are trying to tell you, number 1, reaction with the aqueous silver nitrate to form a precipitate which dissolves in aqueous ammonia is a properties of the chloride ion where AgCl can dissolve in ammonia. Okay, so and then the reaction with aqueous sodium hydroxide to form salt and water is acidic properties. So it can be HX, it can be HOX. Okay, so A is already wrong. D is also wrong. Okay. Then C, it decomposes on the presence of the sunlight to evolve the gas. So this is a property of a HOCl, where the equation for the decomposition of the HOCl under exposure of the UV is 2HOCl under UV. You form CO2 plus 2HCl. Okay, so this is what happened during the decompositions in here. So the best description that describe all this in here is C. Okay, it's a mixture of HCl and HOCl. Okay, so that is for question number 4. Okay, then immediately we go to question number 5. So question number 5 sounds like this. The reaction scheme below shows the reaction between potassium bromide with concentrated sulfuric acid and with aqueous silver nitrate following by dissolving concentrated ammonia. So you first dissolve in potassium bromide, you give a vapor K. So in here, you react with AgCl to form precipitate M, and then concentrated NH3 to form solution N. So the question already highlighted saying that it is a potassium bromide. Okay, so you will expect the vapor to be what color of vapor? It will be brown vapor. Okay, the color of the vapor is brown color. And then precipitate given when you dissolve in MgCl is cream precipitate. And then these cream precipitate are able to dissolve in concentrated ammonia to give the complex according to the equations in here. I write down the equations in case if you want to refer. So AgBr plus 2NH3. Okay, so form AgNH3 2Br. Okay, so you form a complex. Okay, so this is what happens. Okay, so the best description in here, which is a colorless solution, of course, and the best description that describes all this is answer A. Okay, so that is for question number 5. Okay, then we go to question number 6. Color vapor which condensed to liquid to obtain is obtained when compound X is heated with concentrated sulfuric acid. So in here, color vapor condensed to liquid. This is a very important key term. Why is it like that? Because if we don't react with the chloride ion, you form HCl, which is color, white color. So it's colorless. Okay, white color, sorry, white color, cannot say colorless, white color. So, and then reaction with Br minus, I minus will form a vapor, which is bromine is brown, iodine is purple. However, iodine under room temperature pressure cannot form liquid. It is either solid or gas because it's sublime. Okay, so all these are trying to tell you that your solution is actually bromine. Okay, so only bromine can condense to become liquid. So the best description that describes this is sodium bromide. Okay. Okay, so this is for number 6. Number 7, which of the following is not a disproportionation reaction? So in here, you have to know how to calculate the oxidation state. So Cl react with 2NaOH to give NaOCl, which is +1, and NaCl -1. So this is a disproportionation reaction. And then in 3Cl2 plus 6NaOH, so you changes from 0 to +5, and then this is -1. So again, this is a disproportionation reaction. NaCl, which is a -1, when react with H2O to form NaHCl and HCl, this is also -1. So this is not a disproportionation. And 3NaOCl, which is +1, disproportionate, become NClO3, which is +5, and NaCl -1. Okay. What is the circumstances that you get for A, B, and C? So A is when you react NaOH in under cold condition. Cold or room temperature pressure, okay? And then this one is the mixture in A, you go and heat up, okay? So that is how you form the reaction D. And then for B, this one is you use hot NaOH, okay? And hot NaOH, when you react with hot NaOH, so it will oxidize, it will disproportionate the chlorine to +5 oxidation state straight away, okay? So the best answer that describe all this is C. Okay. Okay, so that is for question number 7. So we goes to the next question, which is question number 8. Diaphragm cells are used in industry to produce in the process for electrolysis of brine. Which of the following is not a product of the process? So diaphragm cell, you use you produce chlorine at anode. According to the half equation, 2Cl minus gives Cl2 plus 2E minus. And then you form hydrogen gas according to the equation 2H2O plus 2E minus give 2OH minus plus H2. And then the 2OH minus will react with the NaOH to form the Na plus from the NaCl because you uses brine. Brine here is NaCl. So you have Na plus, so that is why you form B. So the only substance that is not formed as a product is A. Okay. Okay, number 9. Astatine is an element of group 17. What is the expected properties of group 17? So since it has a position lower than that of the iodine, so you expected it is a black color, okay, black color solid, and which is a weaker oxidizing agent compared to the iodine. Okay, so the answer is A. Okay, so that is for question number 9. Realization, let's move on to question number 10. An aqueous solution of the sodium chloride and sodium iodide are added to silver nitrate. Both mixture is then added to concentrated ammonia. Which of the following graph represent the height of the precipitate formed after the addition of each of the reagents in here? Okay, so when you added AgCl, okay, because of the KSP of the AgCl, AgI is higher than that of the AgCl, so we will expect more precipitate on when you add it with silver nitrate to the potassium iodide. So in here, this is correct, okay, compared to this one. So this is not correct. So A and C is already out from our choice, okay? Okay, then when you dissolve in ammonia, so because the reactions are soluble, okay, the silver chloride are soluble in the ammonia, so the precipitate dissolve to form Ag NH3 2 lah. Okay, so that is why the precipitate decrease, whereas NaI does not react with the AgI, no reaction with the NH3, so you cannot. So that is why the best answer that describe all of these are actually D in here. Okay, so that is how you answer for question number 10. Okay. Immediately we goes to question number 11. Solution P, when heated with concentrated sulfuric acid, give off a reddish brown vapor of obviously is bromide. Okay. Solution Q, when reacted with an aqueous solution of silver nitrate, give a yellow precipitate, which is obviously iodide, which does not dissolve in concentrated ammonia. What are the halide ions found in X and Y? P and Q lah, sorry, supposedly P and Q lah. Sorry, I typing error. Okay, so P is as I mentioned, is Br minus, okay? And then Q is the I minus in here, okay? Okay, then we have question number 12. The reactivity of the halogen, chlorine, bromine, and iodine decreased down group 17 of the periodic table. Which properties influence the trend of the reactivity of the halogen? Okay, so we are talking about chemical properties of the halogens in here. So the chemical properties is definitely influenced by the because group 17 are preferably to accept electron. So therefore, the factors that influence the reactivity of the halogens are atomic radius. Okay, you must have a smaller atomic radius, easier for it to accept electron. You must have bond energy, easier to break, easier for it to form atom and to accept electron, and therefore has higher electron affinity. Okay, so in here, the factors that will influence the reactivity of the group 70 are 1, atomic size, 3, electron affinity, and also bond energy. So the answer is 1, 3, and 4 of C. Okay, so that is for number 12. Then we go to the next question, which is question number 13. A solution was prepared by dissolving a small amount of potassium bromide and potassium iodide in water. The solution form is then added with aqueous sodium nitrate solution, a silver nitrate solution, and then by concentrated ammonia. What are the reactions that might take part? Okay, so the moment that you add silver to the bromide and iodide, of course you form silver bromide and silver iodide accordingly lah. So 1 and 2 is correct. However, only silver bromide can dissolve in concentrated ammonia, but silver iodide cannot. So 3 is correct, but not 4. So the answer in here is 1, 2, and 3 only. Okay. Okay, so that is for number 13. Then we go for number 14. X is an element of group 17 in the periodic table. Hydrogen halide dissociate according to the equation 2H2 give H2 plus X2. So the dissociation constant of the hydrogen halide at 800 degrees Celsius are shown below. So dissociation constant Kc for HF is 1.4 times 10 to the negative 4, which is very not high, quite low. And then HCl can easier be broken, HBl even easier, and HI is even higher. So greater the Kc in here, greater the Kc, the more the equilibrium shift to the right in here, because that means you have more products. Okay. So which statement explain the thermal stability of the HX descending down to the group? Number 1, relative molecular mass increase. Now, these are obviously due to the how easily or how readily HX is broken. So this measuring HX broken is definitely using the factors of the bond energy. Okay, the bond energy. So what influence the bond energy? First is the atomic radius, then bond length, then bond strength. Okay, so in here, the best answer that describe why is it that the K value increase going down to the group is due to the length of the HX bond increase. So that is for number 14. Then we go to number 15. A new element known as Ramin is discovered and categorized as group 17 below S13 in the periodic table. Which statement about Ramin are true? Number 1, hydroramic acid HRY is a stronger acid than HI. So this acidity increase when going down to the group. So number 1 is correct. Okay. Okay, ramide ion Ry is reduced to Ramin solid Ry2 and when added to concentrated sulfuric acid. So since bromide and iodide can react with the sulfuric acid to further reduce to become their respective element. So ramide even can. So 2 also correct. And then standard electrode potential of the Ramine is more positive than fluorine, which is wrong because when going down to the group, E naught value will become less and less positive. So therefore will be less positive, not less, more positive. And last but not least, Ramine react with hydrogen gas to form hydrogen ramide under room temperature, which is not wrong. If hydrogen iodide, you already require 450 degrees Celsius. So Ramine, which is much more below than the iodine, will not be reacting with here. So the best description of all this is answer A. So this is question number 15. Then we go to question number 16. HX, X2, and H2S are gas evolved when compound KX is heated with concentrated sulfuric acid. So X is what? X is very obviously an iodine. Okay, so they are trying to describe the reaction of the iodine, where at first Ki react with H2SO4 to form NaHSO4 plus Hi, and then Hi is oxidized by the H2SO4 to form H2S plus 4I2 plus H2O in here. Okay, so very obvious. So number 16 is D. Number 17, the element of the group 17 from chlorine to iodine of the periodic table are the most reactive nonmetal in each of the period. Which property of the element that increase descending down to the group? So in here you have to understand what are the properties that increase when going down to the group. First is definitely atomic radius, then melting point, boiling point increase because they are all simple covalent molecule held by weak van der Waals forces. And then what else is increasing? No more. Okay, the rest are decreasing. Okay, including electronegativity, electron affinity, ionization energy, chemical reactivity, bond energy. So all of them are decreasing here. Okay. So in here, the best answer that describe all this is enthalpy of vaporization. Okay. So because this is influenced by the strength of the weak van der Waals forces, okay, which are increased when going down to the group 17. Okay, so that is for question number 17. Then it goes to question number 18. The halogens are important chemical in our daily life. Which statement about chlorine, bromine, iodines is true? So the halogen can act both oxidizing and reducing agent, which is incorrect. Because most of the time, halogen usually is used as oxidizing agent, but it's seldom reduced. The strength of the weak van der Waals forces increase to form Cl2 and I2. So the strength of the van der Waals forces does increase because they are simple covalent molecule. Cl2, Br2, and I2 are formed when their respective halide is react with concentrated hydrogen sulfuric acid. Only bromine and iodine can react. And then Cl2, Br2, I2 react vigorously with hydrogen gas in the presence of UV. Only Cl2 react vigorously with H2 with the presence of UV only. Okay, so the best answer that described correctly is B. Number 19, chlorine is bubbled into a concentrated solution of aqueous sodium hydroxide. The equation of the reaction is shown below. So these are the two equations. Which statement about the reaction is correct? So in here, you try your best to make sure that their mole is the same. So in here, since you have 3 NaClO, so we make sure that the whole equation multiply by 3. So you shall have 3 Cl2 react with 6 H2O NaOH with 3 NaCl plus 3 NaClO plus 3 water. Okay, 1 mole of Cl2 form 1 mole of NaClO. So the ratio of the Cl2 to NaClO 3, okay, is 3 to 1, as you can see in here. So A is wrong. B, anion form are weak conjugate base. The anion forms are weak conjugate base. So in here, because the acid is actually strong, okay, so the anions form a strong conjugate base, not strong weak conjugate base. The oxidation state of the Cl changes from 0 to -1 plus 1 n plus 5. So the oxidation state of chlorine in here changes from 0 to -1, then this is +1, and then this +1 change to -1 and +5. Okay, so the oxidation state of Cl changes from 0 to -1 and +1 only. Okay, then it is the NaClO3 that further changes to -1 and +5. The final reaction is fast at room temperature. Actually, it is slow because you only require heating to make the reactions this one. So the best answer in here is A. No, not A. Sorry, I made a mistake. The best answer in here is B. I think the anions form a weak conjugate base. Because the acids formed in here are strong. Wait, let me check again the questions. Okay, so because NaOH, because this is oxidation, so the best one is C. C. The oxidation state changes from 0 to -1, +1, and 5. So these are the changes of the Cl. C is correct. Sorry for that, my mistake. So the best answer that describe all this is C. Okay, so 2019 is C. Pardon my mistake. Okay, number 20. Which of the following gaseous hydride is most readily to decompose on this element on the contact with a hot rod? So in here is actually hydrogen iodide decomposed to become hydrogen and iodine at room temperature. Okay, so that is for number 20. Then we continue to question number 21. An aqueous chlorine is added to aqueous sodium iodide and the mixture is shaken with equal volume of tetrachloromethane. What will be observed? So when chlorine react with the this one, you will form NaCl plus I2. So you form a brown solution. This brown solution, when you add it to CCl4, it will form purple. And since CCl4 is less dense than water, the CCl4 layer will be on the top, while the aqueous solution will be at the bottom here. Okay, so the best description that describe all this is boy B. Not all iodine will dissolve in this CCl4. There will be definitely some of it still left inside aqueous solution. Okay, we have already seen the video previously, so I hope that you still remember that. Okay, so that is for 21. Then we goes for 22. When excess concentrated sulfuric acid is added to separate solid sample of sodium chloride, sodium bromide, and sodium iodide, which set of halogen-containing substance is produced? So you produce NaCl when you add it to H2 or H2SO4, you form NaHSO4 and HCl, so you form HCl. Then when you react NaBr to H2SO4, you form HBr. Then some of the HBr is further oxidized to become Br2. Same goes with hydrogen iodide, sodium iodide. So we react sodium iodide, you form Hi, and some of the Hi will reduce to I2. Okay, so the best combinations that describe all of these product presence inside here is D. Okay, not all, not all will reduce, some, not all. You still have some HBr and Hi at the end of the day. Okay. Okay, so the best description in here is D. Number 23. The solubility of the silver halide in aqueous ammonia decreased from AgCl to AgI. What helps to explain this trend? Okay, so in here, it is in AgX. X is a free ion, not a ligand. Therefore, NH3 is not displacing Cl minus or Br minus and I minus. So therefore, A is incorrect. So Cl minus and Br minus form complexes with ammonia, but iodine does not. So it is not in here. The Cl minus and Br minus form complexes with NH3. Actually wrong, this statement. It's not Cl minus and Br minus. It is the Ag that form complex, not Cl minus and Br minus. So B is incorrect. And then C, the value of the solubility product of the silver halide decrease. Yes, that is why the solubility decrease in here. Okay, so C is correct. And then finally, AgX, the covalent bond between silver ions and also the halogen increase. No, AgI is actually, AgX is actually ionic bond. Okay, so number 23 is C. Okay, sorry for my mistake again. Huh? Okay, so this is 23. C. Then we go to question number 24. Table below shows the result of experiment in which halogen X2, Y2, and Z2 are added separate solution of X minus, Y minus, and Z minus, which set of X, Y, Z in order of their decreasing reducing strength. Okay, so in here, when when X2 are able to displace let's say that in this case, not X2, sorry, X2 does not react. When Y2 can displace X minus, that means you form X2, correct? So Y2 is a stronger oxidizing agent. Okay, so we are going to see how many tick does each of them has. So in Z2, X2, you does not react with X, Y minus and Z minus, so therefore you have no thing can oxidize by it. So X2 is a very weak oxidizing agent. And then Y2 can displace X minus and also Z minus, so you have two tick. So that means it is the strongest oxidizing agent. And then Z2 can only displace X2, but cannot displace Y2. So therefore, it is this one. So in terms of oxidizing agent, the arrangement is Z to X, X2 is weaker, is weaker than Z2 and weaker than Y2. So Y2 is the strongest. But now we are looking at the decreasing strength as a reducing agent. So in terms of reducing agent, so you have X minus, you have Y minus, which is the weakest reducing agent, then followed by Z minus, followed by X minus. So this one as the strength of reducing agent. So oxidizing and reducing agent are terbalik, so you have to bear that in mind. So the strongest is X minus, followed by Z minus, and then Y minus. So the answer is B in here. So that is how you are going to determine which one is a stronger and weaker oxidizing agents in here. Okay, and we are going to have a look at the last objective question for today. So the last objective question for today is 25. Chlorine compounds show oxidation state ranging from -1 to +7. What are the reagent and condition necessary for the oxidation element chlorine compound containing chlorine, the +5 oxidation state? Okay, so the one where it can form +5 in here is the reaction with hot concentrated NaOH. In the reaction of the AgNO3, you form Ag plus Cl minus, you form AgCl that eventually react with 2 ammonia. Okay, to form AgNH3 2Cl. So this one still -1, -1, -1, no change. And then concentrated HCl, NaCl can react with the H2SO4 to form NaHSO4 plus HCl. So in here only acid-base theory. So this one still -1, this one still -1. Co-dilute NaOH, Cl2 react with the M2NaOH to form NaCl plus NaOCl plus H2O. So in here, you changes from 0 to -1 and +1. Okay, so it cannot be oxidized to +5. Therefore, D in here is the best answer. Okay. Okay, so I guess that is for our first part for chapter 6 today. So we shall continue our discussion on our next video lessons. So we are going to discuss the rest of the objective and also the structure questions. Okay, so see you all in our next video.